Good evening, ladies and gentlemen, and welcome to this day two of Lean Six Sigma Green Belt Hackathon. How are you doing? Just type what is your mental condition, what is your physical, emotional condition. Type in the chat box. How are you right now? In one word, if you have to describe your state of mind, what would be that word? Type in the chat box. It can be amazing, enthusiastic, tired. It could be frustrated. It could be, ready to learn. Whatever it is, just type in the chat box. Everybody. Is my voice loud and clear? Just give me yes in the chat box and let's start the journey. हाँ जी, okay. एक मिनट मैं chat चालू कर देता हूँ. Okay, yes, now you can type because the chat was on. Chat was not on. Yes, now you can type the word. How do you describe yourself today, right now? Then we'll start the recap and then we'll, good evening. Excited, amazing, superb. Okay, a little tired. Okay, good. Enthusiastic. Okay, superb. Good. Okay, good evening once again, and let's start our journey. Can we quickly recap from where we had left yesterday? Okay, can we do that quickly? What have we covered yesterday? चलो फटाफट एक बार recap करते हैं. Can you just type in the chat so that I can quickly do that? I'll just revise that. And then we'll start the day two, which is very important, very excited. Yes, type in the chat box, everybody. Just type in the chat box. Just give me a second. Let me just grab a water. Okay, so it's project identification, project selection, SciPoc, stakeholder analysis, communication plan. Very good. What else? Type in the chat box, everybody. और क्या देखा था? Vocabulary, Kano model, MSA देखा था क्या हम लोगों ने? Kano model, and then yes, the stakeholder analysis, RACI metric. Very good. Internal and external project selection. So in the measure phase, what we have seen types of measure. If you remember, input, output, and process measures. Correct? Then the type of data, which is nothing but, the continuous data, discrete data. What is statistics? The basics of statistics we have also covered yesterday. If you remember, yes. So basics of statistics we have covered, and what is statistics? Science which converts data into information. And in statistics, there are two parts we have studied, which is descriptive statistics and inferential statistics. In descriptive, again, there are two branches, which is, the first one is the central tendency. The second one is the dispersion, correct? So in the central tendency, we have mean, mode, median. Second, in the dispersion, we have range, variance, standard deviation. So this is what we have covered yesterday, correct? Everybody? Yes. Everybody with me till now? Just give me yes in the chat box. If you missed day one, we have all shared the recording of it, and recording is available not in masterclass archive. Okay, so if you want to check the recording of the Green Belt Hackathon, there is a Green Belt Hackathon folder. Okay, so there is a Green Belt Hackathon folder. So you will find it in your LMS system itself. There you can find the recording of day one. Okay, and today's recording also will be kept below that. All right. So recording, it was shared on, on your WhatsApp as well. But if you, in any case, if you have not got it, then you can check out with Greenbelt Hackathon. Okay. Now, why we are doing the recap, and always whenever you are giving the training, let's say going ahead, if you become a trainer or a consultant in this field, always whatever you have covered yesterday, the previous day, you should take the recap of it because of the rule of 86-14. Just remember this. Everybody just type, or you can write like this: 86-14. Can you just write this? Just like 80-20 Pareto principle, there is a rule called 86-14. Can you just type 86-14 and let me reveal this rule for you. Very, very important. Not able to see the screen, is it? Okay, let me share this once again. Okay, now can you see it right now? Can you see the whiteboard which I have written GB Hackathon recording, and now 86-14. Sumanji, just give me the confirmation so that I can proceed further. Okay, meanwhile, what is 86-14? Just try to understand this. 86-14 is a rule of memory. This is a rule of memory. What does it say? It says whatever we learn, whatever we hear, whatever we study, whatever we comprehend, whatever we understand in that day, we forget 86% of that content on the same day. A lot of you would be surprised to know this. 86% of the content is lost in the same day. So whatever we covered yesterday in 3 hours or 2.5, 3 hours, everything 86% is already lost. So if I do not revise it, recover it, it will be lost. So in the next day, so whatever is remaining 14%, right? 86%. If it is not revised, 86% of the remaining 14 also will be lost in a day too. Okay. So this is how over the period of maybe 4 to 5 days, you completely forgot. You will completely forget whatever you have studied, few days ago. That is the reason we always have to do the recap. Okay, are you clear? Just give me yes in the chat box. So it's a new information. As a trainer, you must remember this statistics. Okay, 86-14. Remember this rule of memory. 86-14 rule. Very good. Chalo, let's move on to the next topic. The next topic is called operational definition. Make a note of this, and I'll give you example of this. The topic is operational definition. Operational definition. Okay. Now, what is operational definition? Operational definition meaning when we collect the data. Okay, I'll give you example that will give this clarity. Okay. Let's say, the aviation ministry, okay, aviation ministry of India wants to check who is the best on time takeoff company in India, the domestic basically the domestic players. So which companies are there? We have Air India, we have the Indigo is there, and we have Akasa is there, correct? And who else is there? SpiceJet. I think SpiceJet, is it there still running? I think yes, right? Okay, SpiceJet is there. So I'll just give you example. Okay. So now the aviation ministry wants to check who is performing best in India as far as on-time takeoff is concerned. Okay, understand this. They want to check who is the best on-time takeoff player in this all the competition. So Air India says, what is the definition of their takeoff? So they ask the question, how do you calculate the takeoff timing? So Air India says, whenever my plane, which is parked in the bay, takes the reverse gear and starts pushing back from the parking bay, starts pushing back the flight, that is their takeoff time. So Air India calculates that. I'm just giving you example, okay? So Air India calculates the takeoff time like this. The moment it pushes back, that is the time they calculate as a takeoff time. Then they ask to Indigo. Indigo says the moment the plane starts taxing towards the runway, that is the takeoff time. Akasa Airlines says no. When we reach to the runway, that is our takeoff time. And SpiceJet says no. The moment plane takes off from the ground after taking the run, and then it takes off the lifts from the ground, that is the time it's a takeoff time for us. Now tell me, all these four airlines are calculating their on the timing of the takeoff differently. Can we compare their timing with each other? Can we compare? Just type yes or no in the chat box. Can we compare? Will it make any sense of comparing this timing with each other and deciding who is the best airline? No, right? We cannot compare their timing because their definition of collecting the data itself is different. So, see, so we have to bring them on the same page. Then only we can compare, no? So Air India's timing is different. Indigo's understanding of takeoff time is different. Akasa's understanding of takeoff time is different. SpiceJet's timing is different. So we have to basically make them to understand one definition. So they have to define a standard definition. That's the reason operational definition comes into picture. In operational definition, we decide what data to be collected. Okay. When data to be collected, where you have to collect the data. Okay. Then what is that? What, when, where? If some of you are aware of 5W and 2H, similar kind of thing you can do in this operational definition, just to bring, and then who will collect the data. Okay. And then how that data has to be collected. That also. Yes. Very good. So what data will be collected, when it has to be collected, where it will be collected and stored, who is accountable to collect the data, and how that data has to be collected, stored. This entire stuff should be clearly defined on the piece of paper, and that is called operational definition. So whenever we are collecting the data in the major phase of Lean Six Sigma project, we must clarify what data are we collecting, who should be collecting the data. So let's say some of us has 3 shift operations, right? Now one person is from the first shift, the morning shift, then the afternoon shift, then the night shift. Now, if all these 3 people have different understanding of their data collection, obviously there will be variation. See, in Six Sigma, we are reducing the variation, right? So whatever are variation inducing points, we are just blocking those points. And this is one of the very important point. We have to define how, what, when, where, who will collect the data, who will record the data, where it will be kept. Everything standard, we have to, we define it before we give it to the people, so that there should not be any ambiguity while collecting the data. Are you clear with this point called operational definition? Just give me yes in the chat box with this example of airline industry. Clear hai? Just give me yes in the chat box. Super clear. This is just to eliminate the ambiguity and eliminate the the variation coming out of the data collection part. Okay. Very good. Very good. All right. Now, how many of you have attended the last live session on Monday, I believe, right? Monday evening session. Who did attend Monday evening session? Who attended Monday evening session? This Monday evening session. Yes. What was the topic? How many of you remember? What was the topic that day? No, Monday was not chi-square test. Chi-square test was on Saturday, I believe, right? What was on Monday? So I told you the 86-14 rule. That's right. Anuj has right. Anuj is absolutely right. It was, okay, yes. So chi-square test was done on the Saturday. Okay. By the way, if you are very new in the system, yes, it was attribute agreement analysis, triple A we have covered. Remember that? Yes, how many of you remember triple A we covered? MSA, correct, exactly. MSA, triple A, we covered that triple A part, correct? Super, yes. Now you remember, right? Very good. So why I spoke about it because, okay, if you guys, anybody who misses the live session, there is something called master class archive, okay, folder where you can find out the recording of that, and you can check the recording, and you can if you want to revise it, maybe you can increase the speed of the recording. Maybe you can take it to 1.5x or 2x, and listen to it once again if you want to revise it. Yes, kappa value and MSA, exactly. Okay, so the topic which we discussed there was measurement system analysis, MSA, measurement system analysis. Now, see, all what we are doing here is basically identifying from where the variation can come. Okay, so as we have discussed, while collecting the data, the variation can come. Now, another part where variation can come, another very important point, which is our measurement system itself. Now, what do you mean by measurement system? Measurement system meaning our weighing scales, our screw gauges, the equipments what we are using, and the people. So people plus equipments become the measurement system. So that measurement system also can generate some variation in the data. Okay, so some kind of variation can get induced because of measurements. For example, let me give a very simple basic example. Let's say you have, and you can try this out. By the way, you can try this out. You have weighing scale at your home, you have weighing scale at your gym, and you have weighing scale in your office. Okay, or maybe in your physician's dispensary. Okay, your doctor's dispensary. Now you weigh yourself in all these three weighing scales. You will find some variation. Yes or no, everybody? Yes, exactly. So all of them show the different weight. Yes or no? Now, what could be the reason? Now, if you do it immediately, let's say within 1 hour of, let's say, traveling, and you do it, your weight is not going to change in 1 hour, right? But your weight is shown differently. The reason being, the reason could be, that weighing scale, there could be some technical reason behind it. The balance of the weighing scale is not proper, the adjustment is not proper, the weighing scale calibration is not done properly. There could be so many reasons. Now if you collect the data from one of the weighing scale or two of the weighing scales, there will be variation. So this measurement system analysis is basically used to counter those variation induced because of measurement system. Okay, so MSA, which is measurement system analysis, what it does is it quantifies. So MSA is done to quantify variation induced because of measurement system. Whatever variation is induced because of measurement system, that needs to be quantified, and this quantification is what basically is done by MSA. Okay, just a second. Are you clear? Just give me as in the chat box. Okay, now, so here in MSA, if you remember, if you have, if you have the MSA, there are two parts. If you have continuous data, then we go for gauge R and R, GRR. And if you have discrete data, then we go for AAA. How many of you remember we discussed this on Monday? Just one day before, okay? On this Monday, we just went couple of days back. Remember, yes? If you have continuous data, we go for GRR. If you have discrete data, we go for AAA. Now, continuous data meaning everybody is clear of continuous data, which can be measured on continuous scale, like height, weight, yesterday we discussed about it, types of data, correct? And discrete data also we discussed, okay? Pass, fail, male, female, go, no go, and count the data. That is the discrete data. So what is GRR, gauge RNR, is basically, now what is R and R? R and R is, just a second. Okay, what is GRR? Just try to understand this. Okay, GRR, R and R stands for repeatability, and reproducibility. Yesterday also, or day before also, I spoke about it. What is repeatability? Yes, repeatability and reproducibility. Repeatability is same equipment. Let's say I'll give you same equipment, or first same sample, I would write, plus same equipment. You can just write this, same equipment and the same person. It's called repeatability. And what is reproducibility? Same sample plus same equipment, but different person. Then it is called as reproducibility. That means, for example, let's say I want to measure the diameter of this pen, and I will take this pen, I will use, let's say, vernier caliper or screw gauge to measure the diameter of this pen. So same sample, one sample I've taken and the same equipment, and I will take the reading. Okay. So, and the same sample is given, the same sample, same equipment is given to me again after some time. If I can give the same reading again, that is called as repeatability. Ability of the person to repeat the reading again. It's called repeatability. And what is reproducibility? If the same sample, the same pen, same equipment is given to different person, and if he also gives the same reading, it is called reproducibility. The different people are reproducing the same result. It's called reproducibility. Are you clear with this? Just give me yes in the chat box. Super clear hai ye? Repeatability, reproducibility clear hai? Just give me yes in the chat box. Clear? Everybody? Any doubt? Clear hai na? Okay. So there is a, so basically this measurement system analysis started in automotive industry. Okay. So in the automotive industry, there's a body which is AIAG, which is Automotive Industry Action Group. So this body basically governs this entire measurement system analysis, the rules and the regulation, etc. So according to them, we should take at least 10 samples. So if you want to check your measurement system variation, take 10 samples. Then you should take at least 3 trials, meaning for one reading you have to take 3 repetition. So 3 trials and 3 people. That means total there will be 3 people, and every person will take reading of one sample 3 times. Okay, and there should be 10 samples. So 10 into 3 into 3, total you will get 90 data points to analyze this entire system. 90 data points. So what we do, we collect the data, and we put that in the Minitab, and Minitab will give us, whether the system is, what you can say, acceptable or not acceptable. And there is a criteria for that. But are you clear with the basic fundamental of MSA? Just give me yes in the chat box. So in the green belt level, just awareness of MSA is covered. Okay. In the black belt level, when we go advanced, then we'll go in the Minitab, how the analysis is done, etc. We can do. Okay. Which one of the sample exercise we have done on Monday. Okay. So right now, so what basically in this, if you are doing GRR, just for your understanding, gauge RNR, then you get a GRR score, which is in percentage. So if you are getting, okay, if you are getting GRR score between 0 to 10%, then you have a best system. Okay. If it is between 10 to 30%, still acceptable. And if it is greater than 30%, if it is greater than 30% variation you are finding, then you need to reject your measurement system. You need to recalibrate, retrain the people, etc., etc. Okay. So these are for the GRR. If you are doing AAA, then you get kappa value, fleece kappa value, right? And yesterday, day before I mentioned about it. If you have, so kappa value is a little different than GRR score. So if it is between 1 to 0.9, that's the best system. If it is between 0.89 to 0.7, still acceptable. And if it is less than 0.7, then you have to reject it. Now, in some cases, it says that 0.7 to 0.5 also, with some variation you can accept it, but it is again a call, industry by industry you can take, but these are some normal generic, what you can say, uh, ground rules which we follow. Clear? So MSA is clear. Just give me yes in the chat box. Take the screenshot of this. So this is how, and when we'll go a little advanced, then I will cover how in the Minitab the worksheet is done, how practically MSA is performed. All these stuffs are covered in the black belt level. Okay. So in black belt hackathon also we cover, plus in the live sessions also we cover these topics like we did, on this Sunday, on this Monday, regarding our AAA. Okay. So one day we'll cover the gauge RNR as well. All right. Super. Now, once this is done, now what we'll do, so we have collected the data, we have done the operational definition, we have collected the data, we have done the measurement system analysis. Now, once all is done, then we'll start collecting the data, and that's where we will start using Minitab. Okay. So how many of you have not yet accessed the Minitab? किसका अभी तक Minitab access नहीं हुआ है? Let me know. Just a second. So what you can do is just send a message to our, this number. I'll give you the number. Okay. Rest of you guys, you can just open it. I'm going to give you some files to, work around. Just a second. I'm just giving you a sample file so that we will cover that. Okay. We'll start with Pareto chart. Okay. Once we collect the data, we have various. Okay, there is a file given in your chat. you can just open that. It says example Pareto chart. Okay, the same file I'm just giving twice. Okay, and the people who do not have this, just send the message to our, SNG mentor number, which is given here in the chat. Just send the message and we will share the steps to access Minitab. Okay. Everybody, once you have opened the file, let me know in the chat the file opened. Yeah, no need to put anything. Just keep it blank. Just click on next. So while doing that, there is a video given to you. Just observe that video and you will be able to do it. Okay. Yeah. In case of any challenge, please send the message on that number and we will be more than happy to support you. Okay. Chalo, have you opened the file which is given to you in the chat right now? Just give me yes in the chat box. If you have laptop with Minitab, then only you will be able to open it. Okay. Click it. Just type yes in the chat box, open in the chat box so that I can proceed further. Done? Done, done, and done? Okay, chalo. So here, there is one fruit exporter. Okay. And he is, exporting multiple fruits. So peaches is one of the fruit he is basically exporting, and he's getting some kind of defects, basically, some kind of customer complaints. So he collects the data about it, and he finds that there are 100 peaches which are bruised. There are undersized 87 peaches, rotten 237 peaches, underripe, wrong variety, and wormy peaches. So these are various different types of, uh, you know, uh, Mr. Vicky, if you have Minitab right now with you, then you can open it. Okay. If you don't have Minitab, as I mentioned earlier, just send a message on this number, WhatsApp number. They will give you the procedure. Just follow that procedure and then you will be able to open that. Okay. Yeah, why it is asking the app? Because you don't have Minitab right now with you. That's why the file is asking which app do you want me to open with. Okay. The actual app is Minitab, which you don't have right now. So just send a message and our team will respond to that. Okay. Super. Now, once so how do you go for a Pareto chart? Then go to stat. Everybody follow this path. Go to stat, quality tools, Pareto chart. Everybody just follow this path, please. Stat, quality tools, Pareto chart. Stat, quality tools, Pareto chart. Yes, just click on that. This window will appear. Okay. Now the defects. Okay. Now in the defects, which column should we put in the defects? C1 or C2? Which column should we put? Type in the chat box. What should be there in the defect column? Everybody think about it and type in the chat box. What should be there in the defect column? C1. Very good. C1 column should be put. So let's double click on the C1, which is problem. Okay. And in the frequency, we have to select C2, which is pitches lost. Correct? Now, below that, there is a option. There is an option called combine remaining defect into one category after that this percent 95. So as of now, see, when do we use this? When do we use this? When we have more number of defects. Let's say, for example, we have 20, 30, 40 types of defects, no? Then we can exercise this option, okay? Right now, we have only 6 type of defects. So we will say that do not combine. Just click on do not combine and click on OK. Everybody got it? Just give me yes in the chat box. Yes? Very good. Super. Now, let's try to understand what is this 80-20? I will show you. I'll show you when to combine and when not to combine. Okay. So, for example, let's say what is 80-20? We have to focus on top 20% of the defects which are impacting almost 80%. So, for example, if I only focus on these 2 defects, let me just draw this over here. If I only focus on these 2 defects, which is rotten and the bruised one, okay, only these 2, they are combining, they are basically impacting 76%. If I work on them and eliminate them from the consignment, then 76% of the fruits defects will be eliminated. Okay, if I cover undersize as well, almost 96% will be lost. The defects will be lost or defects will be reduced, I would say. Okay, so this is called the power of Pareto chart. Are you clear? Pareto chart clear hai ye? Let me cover what do you mean by combining this to 95%. Now, what happens here, if let's say I have 20 defects, imagine there are 20 defects. What happens is, then the chart becomes very, very clumsy like this. Okay. So it looks like this, then this, and then this, and then, like this. So because the contribution is very low. Okay. If there are 20 categories like this, so most of them contribute to 0.1, 0.2 kind of a thing. So they do not matter a lot. What matters is these 2 or 3 categories. Okay. So what software does, it combines after cumulative 95%, no? The last 5%, it combines at others. So it will be a small, what you can say, a small bar chart as others, 95%. So all small, 0.1, 0.2% contributors are combined in the last 5% and shown as others. So they are very insignificant contributors actually. Okay. So right now we have only 6 types. That's why I told you that do not check that. Okay. Let's do this thing. Let's select that. Okay. Just go to just select Control D. Control D is what? Control E, sorry, Control E. Just press Control E. If you put Control E, you will come back to this. Now here, let's put this combine remaining defect. Okay, click on this 95% and just click OK. Now you can see here, the remaining 3, they have combined to others. Can you see here? Everybody, have you understood this? Because they are very, very insignificant contributors. They are not contributing heavily. So you can see that the overall last 3 contributors are contributing only 4.3%. Clear this combining of 95% wala? After 95% wala, just type yes in the chat box. Clear, everybody? Shekharji, are you clear with this? This combining wala case. Very good, very good. Super, super. Okay, good. All right. Are you clear where to use Pareto chart in your company, in your process? Are you clear of that? Just give me yes in the chat box. Yes, no in the chat box quickly. Can you give me one example where you can use it in your process? Meanwhile, let me give you a file. Okay, new file. Okay, I'm giving you a new file where we will do some further analysis. Okay, type in the chat box. Okay, internal rejection, very nice. PPM, super, where you can use it. Okay, customer complaints, you can do it, very good. The defects, super. Internal defects, correct. Quality defects, yes. और कहाँ पे यूज होगा? रिजेक्शन एनालिसिस, सुपर. ओके, क्लियर है ना ये? दिस पार्ट इज क्लियर? Very good, very good. Super. Now, let's open this file, new file here, which I have given, which is process capability normal. Yeah, so see, if you have the culture of Lean Six Sigma, definitely Minitab will be used in that organization, because Minitab is one of the very, what you can say, very old software, I would say. Very significant software, significant contribution is there. So you will always find Minitab application in all the companies where Lean Six Sigma is followed. Okay. Yes. Very good. Okay. Now let's open this file now. And once you open the file, let me know in the chat that I have opened the file. Okay, let me just close this. Super. Okay, have you opened the file? Just give me yes in the chat box. Okay. Yeah, the file which I have shared, let me share it once again. This file in the chat. Okay. Hope you have Minitab with you. Then you will be able to open this file on your laptop. The name of the file is process capability normal. Okay. Yeah, let me also open the file for you and then we will start. Now this file, we are going to use it for multi-purpose. Okay. A multi-purpose file app, which is so there is chocolate weight in grams is given in the column. Okay. This is what basically we are going to use. All right. Now, so the first thing what we are going to do is we are going to do a statistical and graphical analysis combined. How we can do that? Go to stat, basic statistics, graphical summary. Everybody please follow this. Stat, basic statistics, graphical summary. Please follow this path. Today's session you will enjoy because it's all Minitab and a lot of things. Whatever we learned yesterday, will be implemented today. Okay. Stat, basic statistics, Minitab. Stat, basic statistics, graphical summary. Just click on that. Just click on graphical summary. This window will appear. Stat, basic statistics, graphical summary is the path. Okay. In this, just select chocolate weight. Just double click on chocolate weight and don't do anything else. Just say OK. In the variable option, just select chocolate weight and just say OK. And you will get this. How many of you got this? Just give me yes in the chat box. Got it? Everybody got it? Just give me yes. Super. You guys are awesome. You guys are learning very fast. Huh? Very nice. Now, what is this? This graph is called as what? Type in the chat box, everybody. This graph is called as? Not variation. Yes, it is called as histogram. Make a note of this. Correct? It is called histogram, which gives us normal probability curve. This red curve is nothing but normal probability curve, right? Now, what is histogram? Just break it down. Histo meaning historical, gram meaning graph. So, a graphical representation of historical data is called histogram. Okay, so whatever chocolate date is there, you remember yesterday, how many of you remember yesterday we discussed about mean, mode, median, and during that I constructed, while mode, it was mode, I constructed a histogram for you. How many of you remember when I wrote 60, 70, 80, 90? How many of you remember? Yes. So it was a histogram which was constructed by me manually like this. Remember that yesterday? If if you missed out yesterday, please check the recording where manually how this can be constructed. Very simple. Okay. So what is the frequency? 1, 2, 3. So that is where we selected the bars and then we created a histogram. Okay. Now, very good. Now this is histogram. This is called as a box plot. Make a note of this. Box plot. Box plot. Okay. Now you will be surprised. Now, because you are not aware of box plot as of now, but I'm going to clarify what is box plot in next 5 seconds. 5 seconds. Okay. Here we go. You know it already. So the box plot, this is the lowest value. I will call it as LV, lowest value. And this is called the highest value. I will call it as HV, which is highest value. Okay, the end, extreme end, lowest value and highest value, which we learn in the range as well. Remember range? Highest minus lowest is the range, correct? Yes. So these are the two values we can see. Now, how many of you remember quartile? First quartile, second quartile, third quartile. This is it. So this is first quartile. This is second quartile. And this is third quartile. And this graph is called as a box plot. Now you can easily correlate. Oh, yes. Yesterday we studied the quartile and percentile. Okay. Now, second quartile is also called as what? Type in, let me see how many of you remember this. Second quartile is also called as what? Mode, mean, median. Okay. Yes. So second quartile is also called as median. The second quartile is also called as median. Okay. And in the normal distribution data, in the normal distribution, mean, mode, and the median are very close to each other. Mean, so if you see here, if you draw a normal distribution data, mean, mode, median are very close to each other and they are in the center. Okay, so this is the central value. Mean, mode, median remain very close with each other and they remain in the center. Are you clear? Histogram and box plot, just give me yes in the chat box. Clear hai ye? Just give me yes. Okay. Very good. Very good. Now, yesterday we remember two types of statistics. One is called descriptive, other is called inferential. You remember that? Just give me yes in the chat box. Correct? Just in the recap also we discussed that. So this part is all about descriptive statistics. Descriptive. Okay. And this part is inferential. Okay, this one also inferential. Yes, yes. Descriptive is on actual. So whatever data we have, okay, let's go here. Mean. Everybody knows mean. Yesterday we have studied mean, right? Which is 42.106. So we have this mean. Standard deviation, sigma, we have already seen how to calculate standard deviation. Variance, remember standard deviation square is variance. Clear? So this is standard deviation is 1.6 and variance is 2.7. Okay. Then skewness and kurtosis is something which we will cover in the black belt level. Okay. Skewness is nothing but see, what is skewness? So see, there is something called normal distribution like this. If it is not normally symmetrical, if it is not there, it looks like this. See the difference between these two. This is a symmetrical distribution and it is unsymmetrical distribution or asymmetrical distribution. Can you see? And this is called a skewed distribution. So to check skewness, there is a parameter. Okay. Anyways, we'll cover that in black belt. N is equal to number of data points. Right now we have 120 data points. Okay. Then the minimum value we can see here. This is the minimum value. Then the maximum value here, right? And then first quartile, second quartile or median, and the third quartile. Are you clear with all these data points? Just give me yes in the chat box. Clear hai ye? Everybody just give me yes in the chat box. Super clear? Okay. Very good. Now let's come to the inferential statistics. Okay, which is also, as I mentioned to you, now let's try to understand what is this. We are not covering right now, but let's try to understand. 95% confidence interval for mean. What does it indicate? So what it says is, now the actual mean is this. Okay, actual mean is this. With 95% confidence, see this is sample data of 120 data points, right? So the sample mean is 42. With 95% confidence, we are predicting that the mean of the population meaning if we take the large data of the same chocolate weights, if we take 1 year data for that matter, example, okay, then the mean of that long-term data would lie between 41.808 to 42.403. ये दोनों के बीच में तो मीन आएगा. That's what the software is predicting. It is called 95% confidence interval of mean. The same goes with, and there is a formula to calculate, by the way. Okay, there is a formula to calculate. If you want to study this, what is the application of this? What is the formula? So we have taken, of course, it is available in black belt, master black belt level as well. But in the masterclass archive also, there is a session you can find on confidence interval. What is CI? How it is calculated and what is a practical application of it? If you are interested, you can check out that. Okay. I'm coming back to that, Girish. Okay. Now the same goes with median. Median is currently 42.1. So with 95% confidence, we are saying that the median of the population will lie between 41.5 to 42.3. And same goes with standard deviation. Right now, standard deviation is 1.645. You know, with 95% confidence, we are saying that a standard deviation of the population will lie between 1.46 to 1.885. Are you clear? ये समझ में आया 95% confidence interval? Just give me yes in the chat box. Concept समझ में आया? That's very important. Okay. Now I'm coming back to, very good. Thank you very much. Now I'm coming back to this part, which is called Anderson-Darling normal test. Are we taking plus and minus 5% from the mean? No. Virendra ji, no. It is not like that. There is a separate formula to calculate it. Okay. It is not from the mean 5% plus and minus. No. Okay. There is a separate formula to calculate. So mean के लिए formula अलग है, median के लिए अलग है, standard deviation के लिए अलग है. Okay. Now coming back to this Anderson-Darling normality test. What is that? What is Anderson-Darling? Okay, there are two statisticians named Theodore Anderson and Donald Darling. Okay, these two statisticians describe this normality test where software calculates a value called p-value. Okay, I'm going to speak about this p-value after our small break, after 8:30. Okay, I'm going to speak about it when I'll be speaking about hypothesis testing. But if the p-value is greater than 0.05, then the data is normally distributed. It's a statistical test. And that's what it's called as Anderson-Darling normality test. Whenever the p-value is greater than 0.05, the data is normally distributed. Okay, and not skewed distributed. Clear, everybody? Just type yes in the chat box. I will share with you. There is another way also you can do Anderson-Darling normality test. Clear yahan tak? This, so we have talked about the histogram, the box plot, the descriptive statistics, all the elements of descriptive statistics, inferential statistics, and Anderson-Darling normality test, which I will cover a little, again as well. Okay. Now, with the same data, now, how do I go back to the data once again? The same data, if I want to go back, just click here. Okay, just see my cursor. So if you remember, I mentioned about these 3 tabs in Minitab. So whenever you are in the Minitab file, these 3 tabs are very, very important. Just observe this area. Okay. The center area is basically where the data is. On the left-hand side, whatever statistical analysis you are doing, so that will be kept in the sessions folder, and whatever graphical analysis will be there, that will be there in the graph. So you can see the symbol of the graph. So bar chart का graph आपको symbol दिखेगा छोटा सा एकदम. Okay. And बीच में जो है वो Excel जैसा symbol दिखेगा. That is a data sheet. And on the left hand side you have statistics. So it's like this: data in the center. On the left hand side, statistical data, statistical analysis. On the right hand side, graphical analysis. Clear? Now, if you want to go back to the data, just click on the central value. So you'll come back to the data once again. You will come back to this data part. Clear, everybody? With me? Just give me yes in the chat box. Anybody behind, please let me know. Okay. Very good. Very good. Super. Is it interesting, whatever we are doing right now? Are you finding it very interesting? हम लोग जो मेहनत ले रहे हैं, it's making sense, right? Your understanding of the subject, your understanding of Minitab, the concepts, is it deepening? Correct? Yes. Very good. Thank you very much. Thanks for the confirmation. Very interesting, mind blowing. Thank you. Thank you. Yes, sir. Yes. Okay. Thank. That's what I just wanted to check whether we are heading towards the right direction or not. Okay. Very good. Okay. Chalo. So let's do if you want to identify the trend. Okay. Now, where do you see the trend chart in our, let's say, stock market, right? Our Nifty index, you go, you see the Nifty index or a particular stock you want to check how everyday performance is happening, going up or going down. So that is called as the trend chart, or in Minitab, we call it as a time series plot as well. Okay, time series plot. So how do you do that? Go to graph and select time series plot. It is from the bottom, the 5th option is time series plot. Just do that. Click on graph option, and from the bottom, time series plot. Okay. So what is time series? Just try to understand. Time series meaning whatever you want to plot, whatever you want to inspect against time. Now it can be your daily sales, daily production, daily defects, attendance, whatever you want to per day or per shift or per week, per month, whatever against time you want to place, this can be done. Okay, just select time series plot. As of now, just go for simple. Just click on OK. Now, just select chocolate weight in this and just say OK. And you will get this. Now, everybody got it? Just give me yes in the chat box if you got this. All right. Very good. Now, can you observe this graph and tell me, what are you observing? What are your observations here? Give me your observations, right? Yeah. What are you observing? Too much variation. Very good. Lot of variation. Not centered. Okay. Not centered. Yeah. We don't know where is the center, but it's not, it's very wavy. So much variation. Now, just go deeper just go deeper. Now let me analyze it a little deeper. Okay. If I see here around this data mark, okay, just observe here. Okay. I can see something has gone wrong here. Okay. Observe the variation before this and observe the variation after this. How many of you can observe this? Just give me yes in the chat box. So around that 50-52 mark, something has changed in the process. So the variation earlier was a little lesser. Variation after that, we can see bigger peaks and the valleys. Yes, are you observing this? So similarly, you need to observe the graph very closely. And you need to practice this eye. You should develop this eye of identifying these kinds of trends and pattern. Now, secondly, I will question these peaks and the valleys. Okay, why this variation? Why these huge spikes? Why these lower points as well? I would inspect. I would go and investigate. It requires investigation. All right. So this is very, yes, deep diving. Now, if you observe very closely, I will see a pattern emerging here. Can you see this is called a pattern? How many of you can observe this pattern where the process is slowly shifting downwards? Are you observing the pattern here? Yes. So these are called small patterns which I need to observe. Can you see here? Yes, these kinds of patterns. So we can question these patterns as well. Yes. So if we put limits, then it is not the time. So right now what we are doing is, Anshumanji, we are just putting it on the graph and observing the trend. Okay. If we put the limits, the upper control and the lower control limit, that becomes the control chart. We'll do it. We'll do it in a while. Okay. But are you clear right now? Just type yes in the chat box. यहाँ तक clear है? Just give me yes. Okay. Time series plot. So where will you use this time series plot in your process? Just give me one example. कहां पे आप यूज कर सकते हो आपके प्रोसेस में इसको? Just give me one example. Just type one example where you can use it effectively in your process. Yes, day-wise rejection data, very good. The sales data, very nice. Day-wise production, shift-wise production, asset trend, productivity versus time, very good. What else? Super. So you understood, right? So whatever against time you want to check, this graph can be used. Yes, very good. Production के लिए, sales के लिए, defects के लिए, asset के लिए, whatever, right? Super. Now, there is something very interesting which we need to remember. A sequence. Remember the sequence. There is a sequence called, and I want you guys to type this sequence. The sequence called SNC. Everybody, please type SNC in the chat box and let me explain you, in this. SN and C. Where S is basically called as stability, which is done with the help of control chart. Okay. N stands for normality, where a normal probability, a normal Anderson-Darling normality test basically, which is performed, which I'll show you, and the p-value is calculated. Okay. And C stands for capability. C stands for capability. Okay. Right, against the time, that time series. So what is the relevance? Let's say there is a process continuing, no? Let's say, Virendraji, there is a process continuing, and I want to check the weight of the chocolate, how that variation of the chocolate weight is being observed. Okay. And what are the reasons for the variation? If I'm making certain changes and adjustment in the process, let's say I change the temperature of the oven. Let's say, for example, I change the temperature, I increase the temperature by 2 degrees. What is the impact on the chocolate weight? That I can find out. Maybe I can, increase the blower speed. Okay, the blower speed, or I can increase the conveyor speed. So all these parameters I can check and test. Okay. So if the process, I'm not going, I'm not doing anything, how the process is varying. Is there is sudden jerk? If there is a sudden jerk, let's say, for example, between 50 and 50 second, around 50-second mark, if we have not changed anything, but still there is a jerk in the process, then it means there has something gone wrong in the system, which if we have made some changes, it is a reflection of that, then we can do the correlation analysis. Okay. So against time, we can basically check how it is flowing. Okay, so a lot of parameters we check against time that's you rightly mentioned earlier, like daily production, daily, so against time, that is also very, very important, because then what happens is, if we get what is the date, what is the time over there, we can cross verify what was the process parameter at that point in time, and then we can make the correlation, and that deepens our understanding of our process. Okay. That's where this process is very important. Okay, coming back to SNC, stability, normality, and then process capability. Process capability is nothing but which sigma level we are into. Okay, is it 2 sigma or 3 sigma or 4 sigma? That is basically process capability. Clear? So now we will check stability, then normality, and then capability one by one. Clear, everybody? Just make a note of this: SNC, stability, normality, and capability. Clear? Now, how do we make stability? It is exactly same like time series plot. Exactly same like time series plot. How do that? Go to stat, control charts, variable charts for individual. Everybody just follow this path. Stat, control chart, variable chart for individual. Just type yes. Stat, control chart, variable charts for individual. If you click on that, just select chocolate weight and say okay. Don't do anything else. And you will get this graph. Everybody got this graph? Just give me yes in the chat box. सबको मिला ये ग्राफ? Just give me yes. Okay, got it? Very good. Very good. Now this is called control chart. Now let me minimize this. Okay, and put both the graphs in front of each other. Okay. Yes. So let me put both these graphs in front of each other. Okay. So that we will compare them. एक सेकेंड ना, इसको कर दिया, then इसको भी कर लिया. Okay. So now let me put it. Here we go. If you observe closely, both the graphs are exactly same with the same data. Only thing is that there are three, what you can say. How can we remember that for the test? So it requires practice, Virendraji. Okay. In your curriculum also, we have given you the screenshots. Okay, where to click. Okay, so that you can just follow the path and see. If you do it 2 to 3 times, now you'll understand which are the frequently used ones. Okay, those many only you need to remember. Okay. So even I am also not using all the 100% capabilities of Minitab. I'm not using it. I'm hardly using 50-60% capabilities. Okay. But a lot of things I'm not using in regular projects and trainings. Okay. Now coming back to this, only there are 3 different lines. First line is called, so let me just increase it. So ultimately, this is the same process, same data points. Only difference is, along with this time series plot, we have got 3 lines in the in this control chart. Okay. So what are these 3 lines? These 3 lines are, let me just maximize it and show it to you. The first line is the mean line. Mean is the average. Okay. The second line is called upper control limit. And the third line is called lower control limit. And how it is calculated? The formula for upper control limit is x bar plus 3 times standard deviation, and formula to calculate lower control limit is x bar minus 3 standard deviation. Okay, now let me give you a simple example so that you can easily understand this. Okay, now imagine if x bar is, let's say, 42. Okay, and standard deviation is equal to 1. Can you calculate upper control limit with the formula and lower control limit and give me your answer in the chat box? Formula is here, x bar plus 3 standard deviation, x bar minus 3 standard deviation. Can you just give me UCL kitna hai? What will be UCL number? UCL, and what is the LCL, lower control limit? Okay. So UCL is 45. Everybody got 45 UCL? Just give me a in chat box. And what is LCL? 39. Everybody got 39? Just give me yes. Okay. Understood? Similarly, software has calculated upper control limit and lower control limit on the sigma. I've just given you one just for our simple calculation. Now, if it is 1 point, let's say 1.1 or 1.2, the calculation would be a little different. That is what is exactly happening here. Clear, everybody? Upper control and lower control limit. Just give me yes in the chat box. These are called control limits. Clear? Just give me yes. Clear enough? Very good. So what it indicates, if any value which goes beyond control limit, okay, that is called, let's say, for example, let's say this value, this is actually exactly on the control limit itself, on the line actually. If it goes beyond this, then it becomes special cause of variation. Make a note of this. Special cause of variation. I'll give you example, practical examples where you can understand. And the variation within these control limits is called as, now this variation I'm talking about, this variation is called as common cause of variation. Make a note of this. Common cause of variation. Anything which goes beyond upper control or lower control, it can go below that as well. It is called a special cause variation. Anything within the control limits is called common cause variation. Just to give you a simple example, okay, if your office arrival time, every day you come to office, okay, and there is always a 5 to 10 minutes variation. If I ask you a question that why did you come 5 minutes late or 5 minutes early, you may not be able to give you the answer because it's a common variation. It's a common, your what you can say, waking up time variation, your preparation time variation, your daily traffic variation. It's a very common. Okay, so pinpointing an actual special reason is very difficult in the common cause variation. Are you understanding? But let's say, for example, one fine day, when you are driving from your residence to your home, residence to your office, and you got your tire punctured, right? And that costed you 1 hour, 1 hour delay. Now, in that case, your data will be, will be like this. It will go outside of the control limit, and that is where the special cause is all about. Special cause is a cause where you can easily identify the cause. It is called a special cause, right? Let's say your another example, your body temperature. Our body temperature also, there are common fluctuations during the day. But when we have the fever, our body temperature increases drastically. Okay, that is called a special cause variation. And the routine, normal, common variation is called common cause variation. Are you clear? Just give me yes in the chat box. Yeah, ये clear है? Common cause and special cause, upper control, lower control limits. Yes, just give me yes. Now, very good. Now, if all the data points are within the control limits, that process is called stable process. Stable meaning predictable. We can predict the process. We can predict the outcome of the process. Okay. This is according to Walter Sheward. Now, who is Walter Sheward? Walter Shewart is father of statistical process control, who has basically devised all these control charts. Okay, according to him, any process which flows between +3 and -3 standard deviation is called as a stable process. Okay, so this, barring this data point, this process is looking very much stable right now. Okay, are you clear with this? Just type yes in the chat box. This data point is also in exactly in the just in the control limit, just touching the control limit. Clear hai? Just give me yes in the chat box. Super clear. Okay. Now we have checked the stability right now. Let's find out the normality. How do we check the normality? Normality कैसे check करते हैं? Go to stat, basic statistics, normality test. Everybody just follow this. Stat, basic statistics, normality test. Stat, basic statistics, normality test. Okay, just click on the normality test. In the variable, select chocolate weight and select OK. Don't do anything else. Stat, basic statistics, normality test. Okay, and just click on OK. And now we have this graph. Now there are a lot of statistics here. So this graph is actually the chocolate weight is on the x-axis and the percentile of that is on the y-axis. Okay. But what we are interested is this. We are interested in the p-value. Do you remember? If the p-value is greater than 0.05, then the data is normally distributed. So the p-value is 0.256. Clear, everybody? So the data is showing the normal distribution trend. What is normal distribution? Normal distribution meaning the symmetrical data, the mean, mode, median are in the center. Okay, that's what it is called, a normal distribution. Okay, so we have seen stability, we have seen normality. Now we'll go for the C for capability. What is capability? Is my process capable? Okay, now for example, let's say customer gives me a limit. Okay, AD stands for Anderson-Darling. AD is called AD value. Now there is a formula to calculate AD value. From the AD value, we calculate a P value. Okay, when we'll go to the black belt level, I will share with you how this P value is manually calculated in various hypothesis testings. Okay, हम लोग manually भी calculate करेंगे इसको. ठीक है ना? So right now what we do is we put it in the Minitab software and just check the P value, and from the P value we infer. Now coming back to capability. Okay, now what is capability? Let's try to understand this. Now how do we find out whether you have cleared the exam of the green belt? How do we find out that? Type in the chat box whether you cleared the examination of the green belt. What is the criteria? Whether you are capable of clearing the exam of green belt. Type in the chat box. What is the criteria? Everybody should know this criteria. Just type in the chat box, everybody. We are just talking about the third factor, which is capability. Okay. Yes, which is 70% minimum passing criteria, right? So 70% minimum passing criteria, everybody knows this. If you score 70 and above, that means you are cleared. So what is 70%? It is called specification limit. Correct? It's a specification limit set by, so in this case, specification limit is, this is called lower specification limit at 70% and upper specification limit is 100%, but it is not specified. So generally we want you guys to score in between these. Correct? Then if you are here, somewhere here, then it is failed or rejected. Then you have to re-exam again. Give the re-examination. Okay. So now here in this chocolate case, let's imagine the customer is accepting the chocolate. So upper specification limit and lower specification limit. Now be very careful about it. Huh? Customer is giving us the specification limit. Let's say 48 grams and let's say 36 grams. Okay. So customer will accept the chocolate within 36 lower specification and 48 upper specification. Now you can get confused between specification and control limits, because just now we have seen control limits in the control charts, upper control and lower control limits. How many of you are confused now in between these two? Yes. So let me touch upon this topic quickly. Yes. So there is a control limit and there is a specification limit. Okay. Let me come to my whiteboard. You can also do this. Make this, a center line like this. Okay. One side, it is control limit, and other side specification limit. You can just for your information. Okay. Now, control limits basically, which we call it as upper control limit, UCL and LCL, upper and lower control limit, and specification में क्या है, USL and LSL, lower specification limit. Now, who decides control limit? The process decides the control limit. Because what is the formula, if you remember? X bar plus and minus 3 standard deviation. That is, so standard deviation is defined by the process. X bar is defined by the process. Okay. But here, the specification limits are decided by the customer. Customer will tell. Now, in our, let's say, green belt, who is the ultimate customer? Let's say CSSC. You use the governing body. So who decides 70% the passing mark criteria? So every person should score equal to or greater than 70%. So customer decides the specification limit. Okay. So control limit, which graph do we use in the control limits? Which is control chart. Okay. And specification limit, which graph we are going to use? We are going to use histogram. Okay. For example, if I put histogram and I put the specification limit like this, whatever goes beyond specification limit is called a defect. Okay, this is the center value, which we are going to do right now. So specification limit, we are going to use histogram. Control limits, we are going to use control charts. Okay. Anything which goes beyond control limits is called as special cause variation. Special cause variation. And anything which goes beyond specification limit is called what? Type in the chat box. Anything which goes beyond specification limit, it's called as what? Everybody type in the chat box. I want everybody to give this answer. Very good. It is called as a defect. Absolutely right. Clear hai? Now it should be clear in your mind. Control limit is set by the process itself. Specification limit is set by the customer. Okay, just take a screenshot of this. So control chart का भी मैं यहाँ पे draw करता हूँ. Just a second, बाद में आप लीजिए. Okay. So control chart we have just seen like this, right? Upper control and lower control limit. And this is a histogram. This is specification. Okay, just take a screenshot so that you will remember this. Clear? Just give me a yes in the chat box. Now we'll go back to our better than the specification limit all the time. No, not necessary. Control limits and specification limit has no relationship as such. Okay. You can have a bad process where very high control limits are there, and a very good process where control limits. See, always a good process will have control limits within the specification limit. That's a good process. And a bad process will have control limits beyond specification limit. Okay, that's a bad process. Clear? But ideally, there is no relationship between control and specification limit. Okay. Now come back to the Minitab once again. Now we'll find out the capability. So how do we find out the capability? Go to stat, quality tools, capability analysis, normal. Just follow this. Does there should be a bad process practically? Yes, there are a lot of bad processes practically. Absolutely, yes. The process which is not in control. lot of variation in the process. Lot of variation is a bad process, right? So our role as a process owner is to make the process in the center. Okay, everybody follow this path: stat, quality tools, capability analysis, normal. Everybody follow this path. Now we are doing the capability analysis right now. Stat, quality tools, capability analysis, normal. Once it is done, let me know in the chat. Okay, just click on that. Now, in the single column, select chocolate weight. In the subgroup size, just put one. Just put one. So we are saying that there is no subgroup meaning if you are taking a group of chocolates right now, then we can say, let's say if I'm taking 5 chocolates to check, then I will write 5 over there. But right now we are considering only single chocolates are taken for analysis. Okay. So the lower specification limit is 36. Upper specification limit is 48. Everybody follow this. Chocolate weight in the single column, subgroup size is 1, lower spec is 36, upper specification is 48. Then I'll go to option. Go to option on the right hand side and just click on benchmark Z here. Benchmark Z. Everybody just follow here. Benchmark Z. Just click on this benchmark Z and click on OK. And then click on OK. You will find something like this. Everybody got this? Just give me yes in the chat box. Now, if you see here, the Z bench, which says 3.93. Everybody follow this process. So if this Z bench value is 3.93, that means my current process is 3.93 sigma process. Almost close to 4 sigma process. Okay. Yeah, I will repeat it once again. Just follow this, okay? Just in the single column, okay? Have you reached to this level, this box? Sumanji, just give me yes in the chat box if you have reached to this box. If no, I will go back again one step, right from the start. Have you reached to this box? Capability analysis, normal distribution. If no, let me just type no. Okay. So I'll just close this and let's say I have this data. Okay, data in front of me. Okay. I'll go to stat. Just click on stat. Then click on quality tools. Stat make quality tools. Click on capability analysis. And the first option is normal. Just follow this path. Just give me the feedback. Just done. Okay. Stat, quality tools, capability analysis, normal. Done. Okay. Why normal we have selected? Because we have checked the normality and the data is normally distributed. That's what we have selected, normal. Okay. Select normal. Now you will come to this. Now here in a single column, select chocolate weight. Just double click on chocolate weight. Subgroup size 1. Lower specification 36. Upper specification 48. Done. Go to option here. There are 4 columns: transform, estimate, option, storage. So we'll see all the transformation, etc. in the black belt here. They're all advanced tools. Okay. Go to option. Here, by default, there will be capability stat CPPP. उस पे click होगा. Instead of that, you need to click on benchmark Z and click on OK and click on OK. Then you will find this value. Got it? Just give me yes in the chat box. Done? आया आपको ये graph with the stats? And just follow this Z bench value, which is 3.93. Yes, very good. Thank you very much for the confirmation. So when your Z bench value is 3.93, that means my process is 3.93 sigma process. And our target is to reach to 6 sigma. So when this Z bench value becomes 6, then my process becomes a 6 sigma process. Clear, everybody? This is my current process capability. And once we improve that, we will do this exercise once again, just to check whether we have improved. Okay, once we reduce the specification limits, variation, then our process capability will increase. Clear, everybody? Just give me yes in the chat box. Super clear? Super. Now, on this note, we will take a quick break for 7 minutes. It's 8:33. We'll be back at 8:40. Okay? हाँ, मैं आने के बाद ये आपको एक्सप्लेन करूंगा ZLSL, ZUSL. ठीक है ना? ओके, वेरी गुड. चलो, let's take a quick break of 7 minutes and we'll be back at 8:40 sharp. Okay. If you're back on your seat, just give me yes in the chat, and let's begin the next topic once again. Just give me yes, 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 yes. Okay, here we go. So let me quickly. Okay, so I just, no, no, it's mine. It's mine. Okay, so yeah, the question which was asked by Yogesh ji was, what is this USL, ZLSL and ZUSL? Okay, see, basically what happens is, um, there are this capability basically, which, because the process is not exactly in the center. Are you understanding? So what happens is, at the lower side, the process capability is a little different than on the higher side. Okay, so because of the shift, if it is on the lower side, for example, let me give you this example. Let me give you this example. If this is the process and this is the scenario, okay, and this is supposed to be the target. Now this is LSL and this is USL. Now this process is clearly shifted towards the lower specification limit. Everybody with me? It has a little shifted towards the lower specification. Just give me yes in the chat box. Because even though it looks in the center, generally it shifts. It keeps on shifting on the lower and the higher side. All right. Now sometimes it comes here, and so whatever goes out of the specification. So if it shifts on the lower side, the process capability on the lower side reduces. If it shifts on the upper side, the process capability on the upper side reduces. Okay. And that's what exactly is basically calculated. Capability status and benchmark Z, option status capability. So see in the options. So let me answer this question first. So these two capabilities are calculated separately. What is your lower specification capability and upper specification capability separately? Okay. Now in this case, the Z bench value is calculated with a different formula. Okay, this is calculated basically with this formula which is given here, which is taken from somewhere here, which is the PPM method. So this Z bench formula can be calculated. Now understand this. There are two ways you can define your process capability. Either you can take the Z bench formula, or rather I would say three types. Three types. Okay. What are the three types? You can see here, these three types are this. Okay. The first one is the Z bench. I generally select the Z bench. You can decide either ZUSL or ZLSL. Whichever value is the lowest, that can be your process capability, or CPK value, that also can be your process capability. These three ways you can define. But only thing is that if you define Z bench, okay, in this measure phase, after improvement, okay, understand this. Define, measure, analyze, improve, and control. So right now we are in the measure phase. We are calculating the process capability, capability. Okay. After improvement also, we will do the process capability analysis. If we are checking Z bench here, so after improvement also, we have to compare with Z bench. If you are taking CPK value here, after improvement also, you have to compare CPK value. Are you clear with this? Just give me yes in the chat box. So whichever observation, whichever value you are selecting, that only you have to stick with in this session. Okay. So right now I have selected Z bench value, which is 3.93. So what is Z bench? So Z bench is, if Z bench is 3.93, that means I can say it is a 3.93 sigma process. Okay. Now coming back to CPCPK. Now, so question what Anuj ji is asking is, why have we selected that? Z, benchmark Z, and why not, why not this one, okay? Why not this CPCPK, okay, by default. So let me click on that and go to option, okay? Go to option and select CPCPK itself, okay? Instead of benchmark, just select CPCPK and click on OK and click on OK. Now, what has happened here is instead of Z bench, the CP formula is calculated. Now, CPCPK is another way of defining the process capability, and you can compare the Z bench and a CPK. There is a comparison. What is the comparison? You can just take down this just for your reference. If your Z bench value is 1, CPK value is 0.33. This is generally you will observe. Z bench 2, this is 0.66. Z bench 3, it is 1. Okay. Z bench 4, it is 1.33. Z bench 5, it is 1.66. Z bench 6, it is 2. So that means when your process is a 6 sigma process, you will get a CPK value of 2. Now, in this case, our process is around 4 sigma. If you really see 3.9 is very close to 4 sigma. So our CPK value is coming 1.34, which is very close to this one. So our process capability is right now this. Clear hai everybody? So either you select CPCPK or either you select Z bench. Both options are given in the Minitab. Clear everybody? Just give me yes in the chat box. Clear hai? Yahan tak clear hai everybody? Okay. Yes. Now, if you want to check each and every element of it, what is PP, what is CP, what is PPU, CPU, CPM, everything, I have a dedicated, CPK is also an indicator, process capability index. It is called as process capability index. Similar to Z, it is also a process capability. See, Z bench, when it started after 6 sigma. Before 6 sigma, it was CPCPK. Understand this? CPCPK was used to be done before 6 sigma arrived. After 6 sigma, now people have started using this Z bench value, what sigma level we are in. Okay, still people using CPCPK as well, and people are using both. Okay, now if you are interested in knowing each and every here, for example, what is PP, what is PPL, what is CPM, okay, what is CPU, CPL, everything, again, go to masterclass archive. Okay, I have dedicatedly prepared a session, process capability report decoded. Like that, there is a session where you will find each and every, formula wise I have given how to calculate standard deviation overall, how to calculate standard deviation within. Okay, now answering the question of what is within and what is overall. Okay, that is one question which is overall. So see, within meaning, it's a short-term process capability. Overall is a long-term process capability. Let me explain you with a very simple thing, just to give you a simple analogy here. If you go to the data, observe the column number 2. Observe the column number 2. In the column number 2 here, actually, there are samples they have taken, 10 samples. Can you see? Sample 1, 1, 1, 1, 1. So there are 10 samples they have taken. That means what? Imagine a conveyor going. Okay, conveyor belt. Okay, the people who are not for the non-technical background people, conveyor is just a belt. When we go to airport, our baggage handling conveyors, right? So they convey the baggage. Similarly, let's say imagine a conveyor and the chocolates are being produced on the conveyor. Okay, and you are a quality person. So you are checking 10 chocolates. You are picking up 10 chocolates for weight calculation as a standard sampling procedure. So now imagine this is one sample. This is the one sample of 10 chocolates. This is the second sample of 10 chocolates. Again, this is the third sample of 10 chocolates, like that. Okay. Now, these are various samples you have taken. Okay. Now you have got within samples also there will be variation, correct? So within samples also there will be variation. And if I calculate the overall, so there will be a overall variation of 120 chocolates. And within also there will be small variations like this, correct? Are you understanding this? every 10 chocolates sample will have some variation. And if I collect all the 120 chocolates together, there also will be some overall variation. So within meaning within those samples, that is called within samples, and overall meaning if I put all the 120 together, that is called the overall process capability. Are you clear with this? Just give me yes in the chat box. So overall within, yes, subset. Sample meaning the subset, subgroup. Clear hai ye? Just give me yes in the chat box. If I calculate, within the samples, I take the average of that. That is called a within process capability. If I mix all the 120 and calculate process, that's called overall process capability. That's the difference. Okay. Very good. Now, once we calculate the process capability, we reach at the end of our measure phase, and then we'll go to the analyze phase. Okay. In the analyze phase, there are basically two gateways you will find. Okay. So here you can make like this. In analyze phase, because we are using Lean Six Sigma, right? So there is a lean tools. There are some lean tools, which we call it as a process door approach or process door. We can see that process door. I'll explain you, just make a note of this. Process door. Okay. And there is another option, which is Six Sigma, which is also called as data door. Now, what is process door? What is data door? Let me explain. PPPPK is a long-term process capability. CPCPK is a short-term process capability. PPPPK is a long-term process capability. The formula remains the same. Okay. Now, what are the lean? When do we use the lean tools in this? For example, whenever you are working on the time-related project, if you want to reduce time, let's say, for example, lead time, delivery time, downtime, are you understanding? Wherever time-related project is there, lean tools are used. Or if you want to reduce inventory, okay, team wood. Everybody remember team wood? How many of you remember team wood? Transportation, inventory, motion, waste. Okay, if you want to attack on this team wood, go for lean type of this one. Okay, now in this lean type of projects or lean tools, what are the general tools in the process door we use? Is process mapping is one of the tool we use, is process map. Okay, yes, process mapping, everybody knows process mapping. Yes, very simple process mapping must be aware of, right? There is another called value stream mapping, VSM. This is also a tool very widely used in this value stream mapping. So we are not going deeper into this right now in this hackathon, because each and every tool will require a lot of time to explain. In the green belt level, you should be at least aware of these tools. Okay. Then we do VA NVA analysis, VA NVA, which is value added and non-value added. VA NVA. I will cover this tomorrow. VA NVA. Okay. So all these tools basically are the lean door or the lean option, lean tools. Okay. On the Six Sigma side, we have tools like Fishbone. Everybody knows cause and effect of Fishbone. Just give me yes in the chat box. Then we use root cause analysis, RCA, vibe analysis. Everybody knows this. In the yellow belt also, we cover this in details. Correct? Yes. Anybody who is not aware of Fishbone and root cause analysis, please let me know. Okay. And after that comes validation of the root causes, and that is done through hypothesis testing and regression. Okay, so today what I'm going to cover is hypothesis testing and regression. Clear, everybody? So in the analysis phase, okay, so rest of the topics are briefly covered in your content, but most important and a little tricky, little difficult topics are hypothesis testing and regression. Okay, rest of the topics you are even either you are aware of, or they are simpler topics to understand. Okay, VA and VA I will cover tomorrow. All right. Right now, I am covering hypothesis and regression. Are you clear? The roadmap of the analysis phase? Just type yes in the chat box. Clear hai? So let's talk about. So I will not cover the fishbone, YY analysis. These are basic tools which you are already aware of. Let's focus on some difficult tools, which is called hypothesis testing. Okay. Very good. Let me just give you one Minitab file. Okay. Very good. And this is a Minitab file. You can just open the Minitab file. I'll give you first we'll do a quick analysis of it, and then I'll give you a background about it. Okay. Let me. इसका कुछ use है क्या नहीं इसको बंद कर देते हैं. Okay, so let me also open this Minitab files right now. Which one I've given you? Okay. All right. Okay, so I think okay, उसको मत लीजिए एक सेकंड. Just a second, guys. दूसरा फाइल देता हूं. इसको इग्नोर करिए. I'll give you another file. Okay, just give me a second. Instead, I will take this one. Okay, this one is better. इसको लीजिएगा. It says example 2 sample t test. Okay. उसको ओपन करिए. Just type opened in the chat box. Done. Open this one, second file. These two files which I have given. वो भी एक्सरसाइज भी चलता है, ऐसा नहीं है कि नहीं चलता, लेकिन आई एम जस्ट गिविंग यू दिस. Okay. Now open, no? Very good. Now let me also open the file and share my screen with you. Now what is happening here? There is a standard process and there is a pilot process. Okay. These are the two processes, right? Now they want to check whether there is any statistical difference between these two process averages. Okay. Now, for example, let's say we have done fishbone and root cause analysis. So we have the root causes. Now these root causes needs to be validated. Okay. Let's say one of the root causes, there is a difference between these two processes. That is the root cause, and we want to validate the root cause. Okay, validate the root cause. So how do we validate the root cause? We'll validate the root cause with the help of data. And that validation is called as hypothesis testing. So what are we assuming here? Hypothesis meaning it's an assumption. So we are testing our assumption. So there are two types of hypothesis. One is called null hypothesis and other is called alternate hypothesis. What is null hypothesis? Null will say that the average of the standard process, which is X bar standard, is equal to average of the pilot process X P bar, which is pilot process ka average. And the alternate hypothesis will say that the standard process average is not equal to the pilot process average. So both are making the equal and opposite comments here. Let's try to understand this. What is the root cause? The root cause says both processes have the difference. And as statistician, as a Lean Six Sigma expert, we should never believe in the opinions. We should collect the data and validate the data with the hypothesis testing. Okay. Now, in this hypothesis testing, what we are doing, we have collected the data of standard process. We have collected the data of pilot process. And now we will be doing, whenever we want to compare two means, there is a process called two sample t-test. Okay. See, when we will go in the black belt level, we will go deeper into what is t-test, what is t distribution, how to calculate it manually, everything we'll do in the black belt level. But as of now, in the green belt level, what we do, we collect the data, we put that data in the software of Minitab, and Minitab will do this testing, hypothesis testing, and it will give us the p-value. Okay. Now, there is the rhyming which suggests p low null go. Okay, everybody, can you just type this rhyming in the chat quickly? P low null go once, at least once. And remember this rhyming. This is a very simple way to understand hypothesis testing and remember this. Otherwise, people get confused. I just don't want to make it confusing here. We'll make it confusing in the black belt level, where I will go deeper into all these concepts of this. Okay, everybody type P low null go. Now, what do you mean by P low? Okay, P low matlab chai P low nahi. Okay, here P low meaning if the P value is lower than 0.05, then you have to reject null. Null meaning this. Okay, see, null hypothesis is called as statement of equality. So this is a equality statement. And the alternate hypothesis is called as statement of difference. This always say there is a statistically difference. Okay, if the p-value is lower than 0.05, then we can reject null. Null go meaning reject null, and we accept the alternate hypothesis. If p-value is greater than 0.05, we cannot reject null hypothesis. We have to accept null hypothesis that both averages are not statistically significantly different than each other. Are you clear? What we need to remember is collect the data, put the data in the software, check the p-value, and from the p-value, we have to make the decision whether there is a statistically significant difference or not. Clear, everybody? Yahan tak? Just give me yes in the chat box. Everybody's clear? Just give me yes. Super clear hai? Very good. Can we just do it with Minitab? Okay. Now let's go to stat basic statistics to sample t-test. Stat basic statistics to sample t-test. Everybody follow this stat basic statistics to sample t-test. When do we use to sample t-test? When we want to compare two processes. Okay. Example, you want to compare between, yesterday I gave you example of KL Rahul and Rishabh Pant. If you want to compare averages of Rishabh Pant and averages of KL Rahul, the scores, then it will be two sample t-test. Okay, then let's click on this two sample t-test. Here in the drop down, okay, just click on the drop down. It says both sample are in one column. Okay, but in our case, both samples are not in one column, but each sample in its own column, right? So second, we have to select because both sample data are in their own column, right? So just select the second one, click on that. In the sample one, select standard process. In sample two, select pilot process. Double click on that and just click on OK. Everybody with me? So get sample one, sample two, select standard and select pilots, click on OK. And you will get this. Okay, two sample t-test. So there is a lot of statistics over here. Okay. What we are interested in this only one value, which is called p-value, which says 0.485. So the p-value here is 0.485. Now, what is our rhyme? P low, null go, right? Now, is it lower than 0.05? The answer is no, absolutely no. It is greater than 0.05. So can we reject null hypothesis? No, we cannot reject null hypothesis. We have to accept null hypothesis. So what was null hypothesis? If you remember, x s bar is equal to x p bar, which is the standard and the pilot process. There is not much difference. So they are statistically, there is no statistically significant difference between first and second process. Are you clear? So they are equivalent to each other. Yes. Now, here is a question. Here is a question to you guys. Okay. Let me simplify this. Just try to understand it. Okay. Now, the first process average is, you can see here, यहाँ पे focus करिए. Standard process average is 14.65. And the pilot process average is 14.34. Yes, everybody with me? Now the question is, so there is, the difference is visible. Now, mathematical difference is there. Of course, there is a small difference. So there is a difference of 0.3. Correct? There is a difference of this. Correct? Yes or no? Mathematically, there is a difference. So why are we doing this hypothesis testing? Understand this. Now, this is descriptive statistic. Understand this. Now, what we are checking hypothesis testing is inferential statistic. The p-value is it's a probability value which is calculating in the long run, is this difference, is it statistically significant in the long run in the population? Sample, there is a slight difference, but is this difference statistically significant? The p-value says no, this difference is not statistically significant for the long run. Are you clear with this? Just give me yes in the chat box. ये आपको समझ में आया? Just give me yes. Everybody just give me yes in the chat box quickly. You remember sample and the population? Sample is descriptive statistics, is all about sample, and population is where huge data set is there. So what is p-value? P-value is a probability. We are checking the probability of that. If the sample variation is this much, will it be, for the population, what will be the difference? Will it be significant difference in the population? That is something which is calculated by the inferential study, which is the p-value. Clear है? वो difference. So you will ask me the question, ये तो mathematically तो है difference. Why are we checking the p-value 0.05 etc. हाँ, blood test वाला example. Exactly, Sumini. Now you got it. Okay, descriptive and inferential statistics. If you remember yesterday, I spoke about descriptive and inferential. So this mean is a descriptive statistic, and the inferential statistics will be what happens to the population. Is it a statistical significant difference? Okay. So this is called hypothesis testing. Okay. So there are, so if you are comparing two means, if you are comparing the two means, okay. Now, I don't want to confuse you here, but let me give you a simple analogy of p-value. You want to see, green belt level में इतना understanding enough है. Just check the p-value. If it is lower than 0.05, reject null hypothesis. If it is greater than 0.05, accept null hypothesis. इतना काफी है. Let me give you a graphical analogy just for clarification. Okay. Now, what is 0.485? 0.485 meaning 48.5%. Are you clear? 48.5%. 48.5% meaning 48.5 divided by 100. If I do that, I will get 0.485. Okay, understand this. It is nothing but 48.5%. Now, how do I read graphically the p-value? Understand this. If this is the standard process, which is averaging at 14.65, and let's say this is the second process, which is the pilot process, जिसका average है 14.34. मैं ऊपर लिखता हूं 14.34. Okay, understand this. एक का average है 14.34, दूसरे का average है 14.65. If I draw these histograms, what is the overlapping area? See, if the total area of both these histograms or graphs is, let's say, 100%, what is the overlapping area? If this overlapping area is, so this is 48.5%, which is nothing but the p-value. How many of you got it? Just type yes in the chat box. if I draw this over, this two histograms, and whatever is the overlapping area, that overlapping area is the p-value. How many of you got it? Just type yes in the chat box. If you haven't understood, it's also okay. Just this is a graphical representation of a p-value I have plotted for you. Clear hai? You don't have to go into the details of it, but this is just for your clarity. Okay? Yes, जितना ज्यादा overlapping area, उतना ज्यादा p-value. जितना कम overlapping area, उतना ज्यादा. Now understand this. Okay, this is scenario number 1. Let me give you another scenario. If the standard process is, if one process is, let's say 14.34, pilot process. Okay. If the another process is, let's say 15. Okay, 15.0. So the distance is greater here. Here the distance is very small, 14.34 and 14.65. Now the distance is greater. Now look at the overlapping area has reduced. If it reduces, let's say if it reduces below 5%, let's say it becomes 4%. 4% meaning what? 0.04. Now, if it is less than 5%, I will say there is a statistically significant difference. See my palms, guys. If it is very close, see, this is my center, the mean and the mean. If it is very close, the overlapping area is greater. So my p-value is greater. So I will say that there is not statistical significant difference between these two distributions. Now, if the distributions are away from each other like this, the overlapping area is reducing. Yes or no? Are you getting this? Now, if it goes below 5%, that means I can declare that, yes, there is a statistical significant difference. Above 5%, I will say, no, there is no statistical significance. If the moment it goes below 5%, I can declare that there is a statistically significant difference between these two means. Are you clear with this simple analogy? Just give me yes in the chat box. Simple hai ye? Clear? Very clear? Virender ji, are you clear with this now? With these two analogies? Super clear? ये आपको किधर भी ये आपको किधर भी नहीं मिलेगा. इतना सिंपल एक्सप्लेनेशन ऑफ पी वैल्यू. ओके, पी वैल्यू में पूरा कंफ्यूज करके रखते हैं, बट दिस इज द सिंपलेस्ट एक्सप्लेनेशन. ओके, एंड दिस इज कॉल्ड हाइपोथेसिस टेस्टिंग. ओके, नाउ लेट्स टॉक अबाउट something called a regression. Very interesting. Very interesting. Okay. Now, when do we use regression? Let me share a file with you, and from the file only we will explain. Okay. All right. So here we go. So the file called scatter plot. Okay. तो ये file एक बार open करिएगा, which I have shared with you, and let me also open the file of scatter plot. Okay. Once you have opened it, let me know in the chat. File opened. Opened? Very good. Very good. Chalo. So let me share the file with you. Okay. Now, there is another way of validation when there is called correlation. Correlation. What is that? Let's say, for example, the test of T, if the test of T is my y, I want to check what is the impact of the sugar content. Sugar quantity का कितना impact है? So my sugar is my x. Okay. So if I plot my test and my x like this, x and y on the graph, let's say the moment I put my sugar, I will find, let's say, a graph like this. For example, if there is no sugar at all, zero sugar is there will not be any test. So it will be 0, 0. Okay. Let's say if I add half a tablespoon sugar, so I will get some test, maybe test at 2. Okay. Then I add another, let's say 1 tablespoon of sugar. then the test might increase. Okay, so maybe up to 2 tablespoons, I will get a positive relationship. Okay, so this is called when my X is increasing and my Y is increasing. My input is increasing and my output is increasing. I will get a trend like this. This is called a positive relationship. Are you clear with this? Just give me yes in the chat box. Are you clear? Positive, my X is increasing, my Y is increasing. Yes. Example, my study time and my marks. More the study time, more is the mark. Yes. It is a positive correlation. Clear hai? Yes. Everybody? Y is the mark and X is the study time. Clear? Very good. Now there is a negative correlation of X and Y. It could be my time on social media, Facebook and Instagram. Let's say as a student, let's say when there is a student and the student is spending more time on social media, Instagram and Facebook, what will happen? More the time on Facebook and Instagram, lower will be the mark. You will get a negative correlation like this. I will share that. Just focus here. I will share the file once again. Are you clear? So this is the study time is X. Let's say Y is the marks, percentage marks. Okay. And X is, let's say, study time. I will get a positive correlation. More the study, more the marks. And in this case, the second scenario, the X is social media. More time I spend on social media, less marks, but there will be probability of scoring less marks. Okay. Now there is another way which is called no correlation. For example, my attendance. Let's say my attendance in my college, maybe that may not have any kind of relationship with my marks, right? Attendance kitna bhi ho, uska marks ke sath koi relation nahi hai. So this is another X and another Y. Correct? So this is called no relationship. So positive, negative, and no relationship. Are you clear with these three correlations? Correlation meaning establishing relationship of my X, which is my input variable, with my Y, which is my output variable. Are you clear? Yes, everybody? सबको क्लियर है? मैं फाइल एक बार फिर से शेयर कर रहा हूं. यहां पे देखिए, ठीक है ना? सबको क्लियर है ना? X and Y का रिलेशनशिप, कोरिलेशन. ओके, पॉजिटिव, नेगेटिव और नो. नाउ लेट्स लुक एट दिस. यहां पे हम लोग करेंगे स्कैटर प्लॉट निकालेंगे एंड फाइंड आउट करेंगे कि रिलेशनशिप है कि नहीं है. ओके, सो देयर इज एन एनुअल प्रॉफिट हियर in crore. This is in rupees crore, and this is learning and development expenses in lakhs of rupees. For example, L&D expense meaning, let's say logo ka training, learning and development ke liye expenses. Okay, so these are the 6 year data they have collected. So first year they have spent 35 lakh rupees in learning and development of the people. You know, the Lean Six Sigma training, soft skill training, leadership training. Only 35 lakh rupees spent kiya. And in that year, they got 4 crore rupees of profit. Okay. Next year, they spent 20 lakh rupees in the L&D of their people. They got 2 crore rupees of profit, and so on and so forth. So we want to just check whether is there a relationship between expenses and our profit. Okay. So how do we do that? Go to graph and the scatter plot. The first option itself is scatter plot. Just click on that. Just click on that. Just select simple as it is. Graph mein first option is scatter plot. Just select simple, which is by default. In the Y variable, there is a profit. X variable, there is expenses in L&D. Everybody just follow this. Profit and L&D expenses. Okay. Everybody with me? Graph, scatter plot, Y and X base select and just click on OK. That's it. Now just observe this dots pattern. Just observe it for 5 seconds and tell me, is it positive correlation? Is it negative correlation? Or is it no correlation? Type in the chat box. P for positive, NE for negative, and NO for no correlation. Everybody, I want everybody's answer in this. Yes. Is it showing the positive trend? Yes. So L&D expenditure is increasing and profit is also increasing. Can you see here? As my L&D expenditure from 20 lakhs to 45 lakh, my profit is going from 2 crore to 7 crore rupees. Yes. So there is a positive correlation over here. Okay. Now let's go one step further and do regression here. What is regression? Go to stat regression fitted line plot. In the same data, let's do a regression. And I'll explain you what is the difference between these two. Stat regression fitted line plot. Just click on this. Stat regression fitted line plot. Click on this. You will come to this. In the Y, select profit, and the X, select expenses. Okay, and let it be the linear model and click on OK. And you will get this basically graph. Okay. Yes, if you got this graph, just type got it in the chat box. Okay. So let me minimize both these graphs and show it to you. So look at this. The first graph, which is a correlation scatter plot, both graphs are actually same. Only thing is that in the regression graph, there are three different factors we have got. Three additional information we have got. Okay, everybody got this, both scatter plot as well as the regression? Yes? Anybody behind, please let me know. Okay. Now, just scatter plot and regression, what is the difference? Okay, difference is only 3 points. Let me just maximize this and explain it to you. The first one is you get the line of best fit here. Okay. Line of best fit. All right. Then you get a regression equation. This is a regression equation. And then you get a R-square value. Now let me explain you all these three one by one. Clear? These are the three differences. If I remove these three differences, then I will get a scatter plot back. Okay. These are additional. Just like our time series plot. Remember that time series plot, and then we got the control chart, right? The same thing here. Scatter plot and this. Similarly, here we have got additional information. Now let's go one by one. So this line of best fit is the line which is passing through these dots. Okay. So there is a statistical formula which is called the least square method. Just for your information, least, L-E-A-S-T, least square method basically is used. So software calculates this line of best fit with the least square method and draw this line for you. Okay. So this is called line of best fit. Now it directly shows us, it will be going like this. It is a positive correlation. If line of best fit is like this, it is a negative correlation. Okay. Like this. If there is no correlation, then generally line of best fit is kind of horizontal. Okay. There is no correlation, right? So this is line of best fit. Now, apart from that, there is, R square. Let me talk about R square value. R square value shows the strength of the relationship. Okay. If R square value is between line of best fit, line of best fit. That means that is the best fitting line for all the, yes, you can fit the line. Okay. Yeah. So if, your R square value is between 0 to 35%, you can say, then you have a very weak correlation. If the value is between 35 to 65%, then it is a moderate correlation. If it is 65% and above, then you can say it is strong correlation. Okay. So here it is 67%, sorry, 76%. It means showing that there is a very strong relationship between your X and your Y. Clear? This is called R square value. Clear with both these things, a line of best fit and R square value. Clear hai? And of course, there is a formula to calculate R square value, which software calculates us. Okay. Again, in the black belt level, we can go to the formula as well deeper. Now comes the last part, which is called this equation. Okay. Now, what is this equation here? This equation is called as Y is equal to A plus BX. Everybody follow this. Y is equal to A plus BX. where y is the output, which is annualized profit. X is your input, which is expenses on L&D. Okay, everybody's with me? This is the equation. This is called regression equation or prediction equation. Y is equal to A plus BX. Okay, Y is output, X is input. What is A and what is B? Let's try to understand. A is nothing but intercept. Okay, and B is nothing but slope. Let me explain you one by one. Intercept is nothing but if I extend this line of best fit, okay, here, if I extend, then where this line of best fit is cutting the y-axis, this point is called the intercept. So you can see here it is minus 1.8. Why minus? Because it is below the lowest value of y. That's why it is going into negative 1.8. So this is called the intercept. Are you clear with this? Just give me yes in the chat box. Intercept clear hai? If I extend this line of best fit towards my y-axis, wherever it is bisecting that, intersecting that, it is called the intercept point. Are you clear? Everybody just give me yes. Give me the feedback. Understood? Yes, intercept. Just give me yes. Very good. Very good. Then comes to slope. What is slope? Slope, try to understand this. What is slope? Slope is nothing but, you can write the definition of slope. Change in y, which is output, with 1 unit change in x. What is slope? Slope is change in y with 1 unit, this is 1 unit change in x. Let me explain you this. Now, L&D expenditure, okay, L&D expenditure is in lakhs. If you remember, between 20 lakhs to 45 lakhs rupees, it is in lakhs. Okay, so 1 unit equals, 1 unit of x is equal to 1 lakh rupee. Let's consider 1 lakh rupees is 1 unit for x. Okay, and what is the unit for y, which is 1 crore rupees? Everybody with me? 1 unit of x is 1 lakh and 1 unit of y is 1 crore. Everybody with me with this? Just give me yes in the chat box. Clear hai? Yes. Now, if I increase my x by 1 lakh rupees, what change in my y I am observing? That is called slope. Change in y, which is change in my output with 1 unit change in x. Are you clear now? Kiska bulb on ho gaya? Just type yes in the chat box. How many of you can bulb on now? You can see here 0.1883. That means what? If I change, and it is plus, you can observe the this sign as well. It is very important. Plus, what it indicates? If I increase 1 lakh rupees expenditure, it is increasing my profit by 0.1883 crore rupees. What is 0.1883 crore? Matlab 18.83 lakh rupees. Are you clear, everybody? So if I increase the 1 lakh rupees expenditure, I am getting 18.83 lakh rupees ka profit, and this is called a slope. How many of you got it? Just type yes in the chat box. With 1 lakh increase in the expenditure, how much increase I'm getting in my profit is called a slope. Clear? Just type yes in the chat box. Clear hai everybody? Just give me yes. Ha. R square value is basically it is called as coefficient of determination. I'll explain you. अभी के लिए आर स्क्वायर ही पकड़ के चलिए मैं एक्सप्लेन करता हूँ फॉर्मूला के साथ, वो एडवांस में सिखाऊंगा आप. ये समझ में आया कि मुझे बताइए. आर यू क्लियर विथ द फॉर्मूला y इज इक्वल टू a प्लस bx, इंटरसेप्ट, स्लोप समझ में आया पूरा? जस्ट गिव मी यस. किसी को डाउट है तो पूछो. सिंपल है. यस. नाउ दिस इज कॉल्ड प्रेडिक्शन इक्वेशन. लेट्स से फॉर एग्जांपल, okay, let's do one example. If I put 40 lakh rupees in my expenditure, how much profit I will generate? Can you just calculate with this formula? Okay, if I put in this 40 lakh rupees, if I put 40 here, how much profit I will generate? Can you just calculate over here with this formula? Formula is there in front of you. So profit, annualized profit is equal to minus 1.817 plus 0.1883 into 40. So first you do the multiplication and इसको ये minus करके you will get the final answer. Can you just give me the answer so that it is confirmation that you have understood this? Okay. और मैं भी ये प्रयास करता हूं. I will also try from my level to calculate it graphically. How will I do it graphically? Look at this. This is a simple method I use. I draw a horizontal or I draw a vertical line from 40 and then I draw a 90-degree horizontal line after that. Okay. So if I draw a horizontal line like this, I will get somewhere around 5.7, 5.8. It must be the answer. So graphically, I have calculated if I make 40 lakhs ka ye, so I will get around 5.8, approximately 5.8 rupees ka, 5.7 or 5.8 rupees ka, of crore rupees ka profit. Everybody, can you just confirm with the calculation, please? $5.715, is it? Very good. Super. Thank you very much. Everybody is getting the same answer. 5 points. So I have graphically calculated 5.7. Okay? Understood? This is how you can predict the value of one variable with the help of another variable. This is called a prediction equation or regression equation. Clear? Just give me yes in the chat box. Yes, everybody. Super. Amazing. So today we will stop here at this point and we'll connect again tomorrow with the day 3 of Greenbelt Hackathon. Okay. And as you have given the feedback that we are enjoying this journey, we will continue this enjoyment tomorrow with improve and control phase. And I will give you the details of the examination as well. Okay. Yes. So the recording will be available in the Greenbelt Hackathon, not in the Masterclass archive. Okay, Masterclass archive में Monday, Saturday का recording होता है. In this recording will be there is separate here which is Greenbelt Hackathon. Black Belt Hackathon का Black Belt Hackathon में होता है. ठीक है? Yes. So you can check out the recording after some time. It takes around 1 hour. It is processing. It processes the recording and then it will upload it. Okay. So you can check out later and practice it on your own. Okay. So till the time, we'll connect again tomorrow. Till the time, keep learning, keep growing. This is Dinesh Patil signing off. Bye-bye. Take care.